surface processes. So here we are going to start our section number 2 in our geology notes. If you open up your green notebook to page 27, we're going to talk about the different types of weathering. So we're moving on to section number 2, which is surface processes, meaning what happens on the surface. We already talked about how sedimentary rocks form by weathering and erosion of our mountains. We're going to focus a little bit more detail on that topic of weathering and erosion and then deposition. So on page 27, you see that there's two different types of weathering, two different ways that Mother Nature causes the rocks to weather. If we take a look at these mountains, this mountain wasn't this tall a year ago. So the mountains are getting weathered and broken apart. So weathering means to break rock or to naturally destroy the rock. Mountains become smaller. Uplift with plate tectonics creates the mountains, and then the mountains become smaller because of weathering. There are two different types of weathering, both physical and chemical. Physical weathering is when we simply just break the rock apart. So here you can see this bottle had Shirley Temple drink in there, which is made up of a lot of sugar and red dye, but mostly it's water. And when this drink was left in the freezer overnight, the water expanded as it turned to ice and cracked the glass. So we call this frost action or frost wedging. You could see here that when ice expands, when the water freezes and turns to ice, it expands. If there's water in a crack, that crack's going to get bigger, and it is strong enough. This frost wedging or frost action is strong enough to break apart rocks. Here we could see on the right-hand side a large rock which has 1, 2 cracks in it and another crack that is now completely open. That's because as water gets in there and when it freezes, it'll expand. So the property that water has, that it expands when it freezes, which is not the norm, can cause rocks to break apart. Some people might assume that this happens a lot in Antarctica or near the North Pole. That's not the case. Since it's so cold there, once it freezes, it stays frozen. But to have frost wedging happen more often, we look at places around our area where there's a constant freeze, thaw, freeze, thaw. So the ice expands and breaks the rock, but then the water melts and goes deeper into the crack and then freezes again. So locations around our area is where we usually find a lot of frost action or frost wedging. And this leads to a lot of potholes as well. Another way to create for Mother Nature to destroy or break apart rocks is by abrasion. And this happens when one rock smashes into another rock. Most of the time, this happens as rocks get tumbled down the stream. If we take a look at this video here, when we look in this stream, we could see the rocks tumbling along. And as they hit each other, they break off. They'll knock apart. And usually, if you have a rock that has some edges to it, it's the sharp edges or the corners which are going to break apart first. Therefore, that causes the rocks to become rounder over time. Crashing waves can crash some rocks into another rock. And when these rocks hit one another, they're going to break apart. And that's another way to physically weather a rock. The longer a rock has been abraded for, especially rolling down a stream or a river, the rounder it's going to be. So we could look at a bunch of rocks and put them in order from the least time that they've spent in a stream to the greatest amount of time that they spent in a stream based on how round the rock is. Rounder, smoother rocks were abraded or weathered for a longer period of time. Mother Nature also provides plants, and plant roots do a great job of wedging themselves into cracks in rocks, and their roots are strong enough that over time the plant can break that rock apart. As we see here, the trees are growing inside the cracks in the rock. They'll break those rocks apart given enough time. So we've seen 3 of the ways that Mother Nature can break up rock. She can do it by the expansion of ice, by causing the rocks to hit one another, and then plants can also break up rock. Those are three of the ways that Mother Nature can physically take a big rock and make it smaller. There's another way to also weaken the rocks, weaken the minerals that the rocks are made out of, and that's chemically changing them. Here you can see a statue that after a certain amount of time uh, got broken apart, and that's because it was chemically weathered and changed. So the minerals actually change with chemical weathering. Water does a great job of softening some minerals. If you poured water on the igneous rock granite, it's not going to change that rock granite at all. But if you let certain rocks and minerals soak in water, they're going to soften and become easier to break up. We also have carbon dioxide. There's carbon dioxide in the air, and when it rains, the rainwater reacts with the carbon dioxide in the air, and it creates a carbonic acid. That acid gets into groundwater and can destroy our limestone rocks specifically. So carbon dioxide, which creates carbonic acid, that gets into the groundwater. It's just slightly acidic and it starts to eat away. If you remember, we started off identifying the mineral calcite. Calcite was identifiable because it fizzed when we put acid on it. Well, the two rocks that are made of calcite, limestone and marble, would do the same thing. So here we see some marble rock, which used to be solid rock here, but as slowly over time some groundwater got seeped into the ground, it slowly dissolved that limestone away and created these caves. Cave systems are almost always in a limestone rock because that's the rock, limestone, which is made up of calcite, which reacts with acid. This could certainly cause some issues when it comes to what happens under the ground. If you live on land that has limestone under the ground, you can have some issues with the ground giving way.
By a sharp crackling sound. The earth had opened beneath them, a dangerous sinkhole quickly growing.
There's a sinkhole right next to our neighbor's house, and it's literally eating the house like completely.
Look at that. The sinkhole. Jose Rodriguez and his family at first didn't understand what was happening, but then scrambled to safety as the walls in their homes cracked and the floors buckled under their feet.
The first time I didn't know what to do, actually. I just saw the house. It was bouncing, cracking, falling apart.
The sinkhole was now 225 feet in diameter, approximately 50 feet deep, and growing as residents in nearby homes evacuate.
Unfortunately, I don't think people in this community are going to sleep peacefully for a couple weeks.
This part of Florida is known as Sinkhole Alley. In 2013, just an hour away, another massive sinkhole swallowed a man after it opened beneath his bedroom. His body was never found. Florida's sandy soil sits on top of a layer of clay and a layer of limestone.
There's that layer of limestone. That's the area where the groundwater is going to slowly eat away at that limestone. As it slowly eats away at the limestone, it's going to then create these caves, and enough weight above is going to create these sinkholes. Mother Nature does a great job of weathering, breaking apart rock chemically. There's another chemical as well besides carbon dioxide, but oxygen. Oxygen reacts with many different elements. The oxygen will react with iron. Oxygen will react with copper. Oxygen will react with many different elements that are found in rocks. When it does, it creates an oxide. The most well-known one is this one here. Here we see iron reacting with the oxygen, creating rust, and that rust is not going to be as strong as the original iron. You guys know this lady here. She's made out of copper, but she doesn't look like this. She looks like this. That green patina on the outside is the copper that is oxidized. If you went up to the Statue of Liberty and used a wire brush and brushed her, not only would you get thrown in federal prison, but you'd also see that there's a nice copper color underneath Lady Liberty, all because she has been oxidized. So there are two types of weathering. We have physical weathering and chemical weathering, and we also have different types under each of those.